Okay. Okay, so while people are still logging on, here is how this is going to go. So I said last week that that we were going to do lecture today and then group work on Wednesday. I think I'm going to kind of split it up. The lecture material I've written might be more like an hour and a half to 2 hours worth. So I'm gonna do half of it at the beginning of today's lecture, and then leave some time for project questions and if you want to do some group work in breakout rooms on Zoom or on your own, and just come back into my Zoom room for project questions, we'll do that. And then we'll basically repeat that same format on Monday. Also, I'm going to send out an email asking people to watch the beginning of this, but the homework for this week has kind of blown up in my face, as you might have been able to tell while you were doing it. So I was gonna bring this up later, but I will just tell y'all now that I'm going to be dropping the lowest homework grade, right, of the quarter for everybody. So take that as you may. So I'm going to drop the lowest graded homework grade of the quarter for everybody at the end, when I'm calculating final grades. I'm going to have to do a rewrite of a couple of the questions yet again. So there's no real way around it. So I'm going to have to repost the homework later tonight after this. I don't really see any way around it. So what I'm going to do is I'm rewriting the questions. I'm just going to provide some code for a couple parts. So for Q2B, and also a little bit in question 1. And so my hope is that for people who are doing this homework, that this will be like minimal extra work for you. And that you'll be kind of more guaranteed to get the problem right. And if you haven't started the homework, or you've been procrastinating and you don't want to deal with all this stuff, there is one homework grade being dropped for the quarter. Okay. Okay, so there we go. So let's just jump into lecture. It's Control L. I think so. Yeah. Okay. So I have changed up my my last week's lecture plan a little bit in light of the events of the last week. This is we have covered kind of everything that my department doesn't give me a super large curriculum for this class, so we've kind of covered everything, I think, that that we were supposed to. So the topic that we're going to talk about for the last week of class is known as quantitative fairness, or algorithmic fairness, and it's going. So we're going to talk basically about how to ethically deploy statistical models and machine learning algorithms, and we're going to see a lot of examples, and we're also going to talk about how we model discrimination and bias in algorithms. So you can probably guess why I've picked this topic, but I think this is probably going to be more interesting than whatever else I might have done, more text manipulation. And it's kind of one of the only things I can think of doing right now that is that from my position is going to be helpful. So yeah, let's jump in. This is also largely my dissertation research. So it's something I am more qualified to talk about than, for instance, regular expressions, which I don't know a lot about. Okay. So let's talk about some different types of discrimination from a statistical or from an algorithmic perspective. I'm recording, good. Okay, so the first type of discrimination that we might think of is direct discrimination. So here is an algorithm, a hiring algorithm that employs direct discrimination. It's pretty simple. The algorithm takes in a person. That's what that require statement is. So it takes in a person, maybe a row of a data frame with information about a person, and then if the person's race is white, then it returns true. It hires them. Otherwise, it returns false. So it's pretty clear why this algorithm discriminates directly. And it should also be clear when you look at this, you should probably think, that's ridiculous. Who would ever do that, right? And so algorithms of this type, like put in practice in computer code, are fairly rare, right? I mean, they do exist, but for instance, you're never going to find Facebook or Amazon or some major company employing an algorithm like this for obvious reasons. Using a computer algorithm like this to do hiring would never stand up in a court of law, for instance. I think it's fair to say that this kind of algorithm is maybe more often found in humans than in machines. Okay, so here's direct discrimination. Easy example. Not for our purposes terribly interesting, because it's easy to discover and it's easy to condemn. The more interesting type of discrimination that occurs is known as proxy discrimination. So here's a slight twist on the previous example, which is an algorithm that discriminates by proxy. So we'll take in a resume instead of a person, right? So the input to this algorithm might be a PDF. And this happens, as many of you probably know nowadays, that a lot of the initial stages of hiring or looking for interviews are done by having machines scan resumes and look for keywords and do other filtering to see which candidates they want to have a human actually take a look at for their resume. So this algorithm discriminates by proxy with this function sounds white, right? So there's some complicated function that takes in a string that's a name and somehow determines if that name sounds like a white person's name or not. So and so if it does, then we interview that person, and if it doesn't, then we don't give that person an interview. Okay, so the reason this is called proxy discrimination is that we are not directly discriminating based on the race of the person, but rather by something different that is associated with the race of the person, right? Your name doesn't directly convey your race. I mean, if I tell you that someone's name is Chad and someone else's name is Jamal, then you may be able to, you may have some idea of which one's more or less likely to be white and more or less likely to be black, but you don't know for sure, right? There's an association. It may be a pretty strong association, but it is still a proxy. Now, this exact algorithm, to my knowledge, is not being deployed. However, more complex versions of this type of discrimination actually do happen. So there was a famous paper about 15 years ago where two researchers generated some resumes, and then at the top of the resumes, they put different names. So you had the same resume with different names on the resumes, right? Pretty clever. So they sort of in a rigorous academic way, looking at data, found names that were most commonly associated with white folks and names most commonly associated with black folks. And so they took like one template resume and put 5 different, white sounding names on it and 5 different black sounding names on it. And then they repeated this for tons of different resumes: good employee, strong appearing employees, weak resumes, all different types, and sent them out at random to different corporations and measured who got called back for an interview. Right, so this was a randomized experiment where the thing that was being randomized was the racial association of the names, and they found that white sounding names were substantially more likely to get called back for interviews than resumes with black sounding names. So the reasons for this might be complicated. It may be that humans were looking at those resumes, reading the names, and either subconscious or conscious bias was expressing itself when they decided who to call back. It may have been that computer at that time, probably it was mostly humans. You could imagine that computer programs, we'll talk about this later, but computer programs could also become susceptible to this type of bias. A computer program could read in the name on a resume and make a decision implicitly based on how that name sounds racially. A related example of this that you probably have heard about was at Amazon. It was in the news. I think I actually talk about this later in the presentation, so I'm not going to spend forever on it. But Amazon had a hiring algorithm that didn't just look at the names on the resumes, but it looked at the resume as a whole, and it did some very complicated, sophisticated machine learning and artificial intelligence stuff that we don't need to talk about. But it basically learned to discriminate against aspects of the resume that were associated with being a woman. So the researchers at Amazon discovered that, for instance, if the resume said women's lacrosse team captain versus lacrosse team captain or men's lacrosse team captain, that the algorithm was less likely to suggest hiring. We're going to talk about the reasons for why that was the case later on, but proxy discrimination in this way does exist. Okay, more proxy discrimination. As you can tell, proxy discrimination, right, that's the thing that is more pernicious, right? When we see direct discrimination, it's fairly easy to call it out, say this is bad, hopefully easy to win a lawsuit and make it stop. Proxy discrimination, not so. Many of you may also have heard of redlining. So by the way, right, a proxy, which you've probably already figured out, is a variable that is strongly associated but not identical to the sensitive attribute that we're discussing, right? So here the sensitive attribute is the attribute that we're worried about discriminating on, and it may be race, gender, nationality, sexuality, what have you. In the early 30s, the federal government, in an attempt to keep the economy strong, provided low interest mortgage loans to people purchasing houses. Now, you do not want to, right? If you give loans to people who are less likely to be able to pay them back, you tend to need to charge higher interest, right? So that you don't lose money on those loans. But what the federal government did here is that they marked up maps based on zip code to decide whether entire zip codes were worthy of federal mortgage loans or not. And And it was the case that the zip codes that were marked high risk and thus not worthy of mortgage loans were very disproportionately Black, right? So it turns out that this was, so proxy discrimination can occur unintentionally. In right, like for instance, in the hiring example before, it's possible that many perfectly well-meaning hiring managers at companies were subconsciously discriminating against people with different names. Now, in this case, it turns out that there's good evidence that the people at the government who were doing this were very intentionally discriminating, that they were using zip code as a proxy for race in order to deny, at least in part, in order to deny low interest mortgage loans to Black people. But there's a little more to the story than that. I mean, because obviously historical systemic racism and slavery, Black people at the time were much less well off than white people, and so on the whole, they were going to be higher risk in terms of paying back mortgages because they had fewer financial resources, fewer job opportunities in order to be able to pay back those mortgages. So there's, it's not exactly a simple story. But you can imagine that there would have been better ways to do this. For instance, today we don't assess your credit worthiness via your FICO score, your credit score, based on your zip code, right? We look at your history with how you've been paying off your credit cards and how your bank account balance levels, things like that, things that are kind of directly and obviously related to your ability to pay back loans. The zip code clearly is not actually, whether you put me in the zip code I'm in now or move me into another zip code, I'm equally creditworthy, right? It's not like zip code actually affects your creditworthiness. Okay, so I'm going to post these slides online, and there's going to be a few links and citations in here. But if you want to read more about redlining, there's a good Washington Post article in there. Long story short, redlining still has impacts today. Owning a house is one of the strongest ways of maintaining generational wealth. And so the fact that Black folks in the 1930s were unable to get mortgage loans to buy houses still has impacts today. The zip codes that were denied mortgage loans back in the day are still are disproportionately Black and poor and lacking in Black homeownership. So I suggest that you read up on that article. Another example is college admissions. So some of you may be aware that, I think this was filed in 2018, but that an organization called Students for Fair Admissions sued Harvard University, arguing that the admissions process discriminated against Asians. There were a number of different complaints in the lawsuit, but one complaint was that places like Harvard, I'm not sure if UW would fall into this category or not. I don't know as much about undergrad admissions here, but that places like Harvard measured things like well-roundedness and uniqueness, right? Did you go on a mission trip to Uganda to build water wells in high school? Were you a Guinness World Record unicycler? Things like that. That they were using those measures in order to decide admissions, in order to downweight more traditional academic achievements, and that was discriminatory towards Asian Americans, who they are, Asians and Asian Americans, and that because they argued that Asian students tended to be stronger in the more traditional academic realms, and that white and other races of students tended to be stronger in these sort of, these other uniqueness or well-roundedness or esoteric realms. So in this case, the argument was that unique extracurriculars were a proxy, right, for being non-Asian, and that, right, Harvard University was using that in order to discriminate against Asians purposefully. And maybe they didn't even need to argue that it was purposefully, but right, the complaint still stands. So last October, I think, October 2019, the Supreme Court ended up taking up the case and ruled in favor of Harvard in this case. So they argued that there wasn't actually illegal discrimination going on. And it's not my point. It's not my purpose to take up whether that was true or not. But I just wanted to fill you in on how that ended up. And you can read, I think there's a New York Times article there kind of outlining the reasons for the decision and what happened there. The point is that these things are not black and white, right? It's not always, right? Determining whether an algorithm, whether it's, I mean, the one in the 1930s, there weren't computers, right? So it wasn't a computer implemented algorithm, but it was a systemic process used by humans to do redlining. At Harvard, it's part algorithm, right? They're having they're having computers read your college applications and humans, but their algorithm was found to not be discriminatory. So why, right? How do these differences come up? How can we analyze them? What's the difference between these two cases, and how do we use statistical modeling to try to understand it? Okay. Right. So there's your summary of different types of discrimination that can be perpetuated by algorithms. Noting that these algorithms can be fully computer or machine-based, they can be human-based, or they can be a mix between the two. So how do we stop it? Okay, so one thing that you might think, the naive approach is fairness through unawareness. If we don't consider race when we make a decision, then we're good to go. And I hope that the previous slides have made it clear that this does not work, right? I mean, it's not like the resumes that you submit. It's not like you're identifying your race on those resumes when you apply to a company. And yet, clearly, you can still be discriminated against on the basis of your race via the proxy of your name or perhaps other things when you apply to a company. So fairness through unawareness basically, as in most cases, does not work because of the problem of proxy variables. Ignoring something like race or gender or income status is simply usually not enough to prevent discrimination in some system. So what is surprising is that the converse often is true. Making decisions that explicitly use race can sometimes be the only fair thing to do. So this is called fairness through awareness, and let's see an example of how it works. Okay, so I haven't written all this on the slide. You're gonna have to listen a little bit, and I'm gonna be running some code in a second here. But suppose that we are an insurance, that I'm a data scientist at an insurance company. And at this insurance company, we need to decide how to price automobile insurance, right? So the more likely you are to have an accident, the more expensive the insurance needs to be, right? So we'll let Y denote the accident rate, X be a binary variable that tells us if a car is red or not, and A be a race indicator that is 1 if you're black and 0 if not. So in this hypothetical situation, what I want you to imagine is that black people are more likely to drive red cars. I obviously don't know if that's true in the real world or not, but certainly you can imagine that people of different races might have different propensities to drive certain cars. Maybe white people love driving Buicks, right? But what is also the case is that there is some underlying trait, which I have denoted here as U, that is unobservable to us, that makes you more likely to have an accident, and Y, right? That gives you a higher accident propensity and also makes you more likely to drive a red car. Now, it turns out that this can be true, and also it can be true that Black people are no more likely to get into an accident than anyone else. How is that the case? Let's look at this code. Okay. So, I think I'm sharing. I'm just going to share my screen so I don't forget to switch back and forth. Okay, so here we go. Let's let n be 1,000. We're going to generate 1,000 examples from the data. We'll generate A as there being 1,000 Black and 1,000 non-Black drivers in the data. Now I'm going to generate U, right? U is this thing that's going to tell us, are we more likely to have an accident and are we more likely to drive a red car? So U is going to be binary with probability, 50-50 binary, right? So U is gonna, I don't want to print the whole thing, right? U is gonna look like that. Now X is going to be another binary variable that, right, that is your propensity, that is whether or not you drive a red car. And we said that both this underlying trait U and your race may determine how likely you are to drive a red car. So again, it'll be binary, but the probability of picking a red car is going to be 1/3 if you are Black, plus 1/3 if you have this underlying trait U, right? So if you are neither Black nor have this underlying trait, there's a 0% chance that you pick a red car, etc. So I'm going to generate that data, and then for Y, I am going to right. Y is going to be your propensity for let's see. I think I'm missing a line of code. Yeah. Y is going to be your propensity to have an accident. So it's going to be some score that describes how likely you are to have an accident, where higher numbers, right, means you're more accident prone, right? I'm not going to turn it into a probability just for illustrative purposes, but right, you can just imagine that that the insurance company assigns some real number score for how accident risky you are, and this score, as you can see, the mean of it depends entirely on U, right? It doesn't depend on A, which is race, right? So race does not affect how likely you are to have an accident. It just depends on the underlying trait U. Okay, so before we start fitting statistical models, what should happen here? Should Black people be charged more than white people for insurance? No, right? No, they should not. Black people are no more, right? Being Black makes you no more likely to have an accident than being white, right? So there should be no difference in how risky we think you are, right? Between Black and white people, right? Should X, right? Should the color of your car determine how risky we think you are for having an accident? Yes, right? If I tell you, right, we can see here when we generated the data Y, it was based on U, and U also determines X. So, right, if I know that someone has a red car, then, right, then I know that that they're going to be more likely to get into an accident. Okay, so let us see. Okay, so let's see what happens. So when we, as the insurance company, build our statistical model for how risky individuals are for having an accident, what regression should we use? Let's see what happens if we ignore race, right? A is race. We observe race and we observe the type of car you have. And if we did fairness through unawareness, then we would not include race in our model, right? And superficially we'd think, oh, this is fair, right? I don't want to use race. So let's see what happens if we just regress y on x. Well, what we can see here is unsurprising. The coefficient for x is positive and highly significant, right? So what this is telling us is that if you drive a red car, then you are more likely to get in an accident, and so we should charge more money to people who drive red cars. All right, so just think for a second. Is this okay? All right, if I use this model to charge people for auto insurance, I'm simply going to check, do they drive a red car? And if yes, I'm going to charge them an extra $40 a month. Does this discriminate? Think about it for a second, and there's no participation grade today. But if you have a thought, type it in the chat. This is a hard statistical question, so that there's going to be no judgment if you get it wrong, right? Or if you it's not like you're going to be racist if you say the wrong thing in the chat. So if you want to take a guess as to what will happen, you can share your thoughts. I'll give you 1 second. Drink some water here. There's a question about whether it discriminates against red car drivers. I'm not sure if that's a thing. I mean, if you come into me with a Porsche, right, then it's not discriminatory for me to charge you more for insurance. I mean, for one, your car is more expensive, so it'll cost more to replace. But for two, if someone comes in with a Porsche and someone comes in driving a Prius, then then I have a guess as to who might be a more safe, defensive driver, less likely to get into an accident. It's probably the person driving the Prius. In fact, women, up until the age of 25, women get charged less for auto insurance than men. That's because men's brains develop more slowly, and we just tend to do more dumb stuff while driving. And so auto insurance companies always charge men more than women for insurance until they become kind of full adults at the age of 25. And you may, you can think about that on your own, but that's perfectly legal and it's generally not considered discriminatory, right? The problem here is that, right, if we charge Black people more for auto insurance, that's a problem because they're not actually more likely to get into an accident in this scenario. Okay, so I'm not seeing anything in the chat. All right, so this would lead to a bad outcome because if we simply just charged people more if they had red cars, Black people drive red cars more often. So on the whole, Black people are going to get charged more for auto insurance than everyone else, which isn't fair. Okay, so what happens? What happens if I do what appears to be the super unfair thing, which is to base my auto insurance rates entirely upon race in this case? Okay, so I do the regression y against A, and because A doesn't have any effect on y, I get an effect that is basically 0, right? The p-value is quite high, so there's no reason to think that this number is at all statistically different from 0. So if I base it entirely on race, then I'm just going to charge everyone the same amount for auto insurance, which is fair. The problem is that there's information that I have that will tell me, right, which people are riskier drivers, right? I know what kind of car they drive, what color car they drive, and I know that determines how risky they are. So as the insurance company, I'm leaving money on the table, right? I'm failing to use information that could help me do better business. So the second model, even though it uses race, leads to a non-discriminatory result, but it's also bad because it doesn't, I'm not using the information that I have in order to sorry, in order to price the auto insurance. So what happens if I use both? What happens if I regress on both X and A? Okay, so if I regress Y on X and A, I get an interesting result. I get an estimated intercept for X that is positive and a little bit higher than in the first example. It used to be 0.36. In this model, it's 0.42. So it's a little higher. For race, I actually get a slightly negative coefficient. And both of these are statistically significant. Both of these are clearly not zero. So what happens if I give out insurance based on this model? Well, either you get a penalty if you drive a red car, but you get a slight discount if you're black. So this is a very counterintuitive situation. But right, what's going on here, right, is that well, if black drivers are more likely to drive red vehicles, but right, less likely, and red vehicles are more likely to get into accidents, but black drivers on the whole are no more likely to get into accidents than everyone else, then it must be the case that the black drivers who drive red cars are actually a little bit safer than everyone else who drives red cars. And so it actually makes sense, right? If we know someone has drives a red car, and we also know that they're black, then they should get a little bit of a discount because there's actual evidence that the black people who drive red cars are safer. Okay, so let's verify. Let's see here. I'm getting a chat question. I don't believe they do, and that's because in practice, this isn't right. This isn't really how it works. Like, I don't think there's any real evidence that like people of different races drive different cars more often, and those cars are more likely to get into accidents. So this example is not realistic in that sense. It is realistic in the sense that that things of this flavor do happen, and we'll talk about some of them later. This example is from like kind of a famous paper on this topic, and it's basically as simple of an example as I can come up with. So I'm using it just to try and illustrate the concept as well as possible. Let's see. So let's just verify real quick. How can I do this? Let's verify that under this system, white drivers and black drivers get charged the same amount for insurance on average. I didn't write this code before class, but I think this will be doable. Okay, let's call this. Okay, so here's the model. Let's get the coefficients out of it, and then we'll multiply them by, right? We'll do this matrix multiplication. You've seen this before. Did I use X then A? Yeah, I did. X A. Okay, so there's my predictions. Oh, whoops. This needs to be an R bind, actually. Oh, whoops. Okay, that's the problem. Okay, this needs to be the first column of this, and then we're good. And I should get 2,000 predictions. Good to go. Okay, so then the mean of the predictions so this is the mean of the predictions for the black drivers. And that's the mean of the predictions for the white drivers. Right? A is 1 or 0, so it picks out. So indexing on A picks out all the black drivers. Indexing on 1 minus A picks out all the white drivers. And check it out, right? The mean riskiness score, which is going to turn into to how much we charge these drivers, is the exact same, right? So under this model that takes into account race, right, and bizarrely gives black drivers a slight discount, or appears to give black drivers a slight discount, in the end is going to charge, it's going to charge black and white driver, or black and non-black drivers the exact same amount for insurance, which is fair because race doesn't have any impact on how likely you are to get in an accident. And it's going to charge people who drive red cars more money, which is fair because people who drive red cars actually are more likely to get into an accident. So at the end of, so you can think about this for, you probably think about this for a bit. And if you, I'd be happy to like talk at the end of the lecture about how this is fair and how it might be unfair. This isn't this is still a little bit of a controversial idea. So you don't have to just accept that this is fair. You may disagree, and yeah, and if you disagree, we can talk about it at the end of the lecture. Okay, cool. All right, let's see. Okay. Oh, I'm not sharing screen. Why did I stop sharing screen? Cool. Okay, so now, I've got this graph here that you saw earlier. So now we can understand this graph a little bit, right? A is race, and we can think of these arrows as saying as being causal effects, right? So in this system, right, race has an effect on which type of car that you own. This unobserved thing U affects both the color of the car that you own and your accident rate. However, there's no arrow between A and Y, right? There's no effect of race on the accident rate. So this graph represents the data generating setup for this problem. Okay, I'm gonna stop for a second for questions. Oh, so how is this related to my research? So my research is about fairness in research grant funding. So what I want to, so the federal government and other agencies have processes for determining who gets federal fund. Just talk about the federal government. The federal government has processes for determining who gets grant funding, right? Who gets funding to do their scientific research, and it's a major problem that that historically women have gotten less funding than men, or have been less likely to get funding than men when they apply, that particularly that Black applicants are much less likely to get funded than white applicants. That there's other disparities, like young applicants are less likely to get funded than older applicants. And so there's a lot of complicated issues at hand. For instance, doesn't it make sense that older applicants with more research experience, who are maybe better at writing grant applications, get funded at higher rates than than young applicants? Is it fair that, excuse me, is it actually fair that Black applicants are less likely to get funded than white applicants? Because perhaps Black professors tend to be at less prestigious institutions, right? Historical educational racism, or racism and disparities in education may mean that that actually is the case, right? At fancy institutions, right? The faculty tend to be quite, tend to not be very many Black faculty. So what we try to do is characterize why these grant funding disparities arise, and whether they arise in ways that are fair or ways that are biased, and what sorts of different types of processes of awarding federal research funding are less biased and lead to better research outcomes, better societal outcomes, that sort of thing. Right, so we face very similar. So that's a real research problem. I mean, this red car thing it's fake, and it's used. I'm using it to illustrate a point. But the real research problem runs into these exact questions. I mean, it's an open question, right? Should we have effectively affirmative action for research funding, right? I mean, right now, as you can imagine, the federal government tries very hard to totally ignore race, right? They try to ignore race completely when they determine their grant funding, right? But are they simply discriminating by proxy, right? Would the actually fair thing to do be to consider researchers' race when we award grant funding? That's the type of questions that we research, right? And you can see how those would be quite similar to the problems from this car example. Okay, cool. Let us, let's go on to the next slide. Oh, okay, so I had a slide summarizing this. Dang it, okay. Okay, right, so the unfair approach is to simply model the relationship. So to summarize, right, it's unfair to just model the relationship between car color and accident rate, because you're going to charge Black people more on the whole, even though race doesn't actually have any effect on your accident risk, right? Fair approaches would be to randomly price insurance and lose money, right? The whole point of insurance is that you're able to figure out who is more likely to have an accident and charge them more. You could model the relationship between accidents and race, right? You could do the Y tilde A model, find their relationship, then you're going to randomly charge, right? Charge for insurance, and you're going to lose money. Or, right, you could model the relationship between accidents and race and car color, charge red cars more, give Black people a discount that accounts for their association with this accident-prone trait, even though they're no more likely to have accidents than anybody else. And then in the end, you end up charging Black and white people the same amount of money, but you also account for this legitimate difference in accident rate between people with red cars and people without. Right? These are all, I think people would say, these are all what I would consider fair approaches. But the latter one is what I would use if I were at that insurance company, because it both allows me to use the data that I have to make money, and also doesn't discriminate, in my definition of discriminating, on the aggregate. Okay. So do we always just do fairness through awareness, right? Should we always just take race into account, or gender into account, or what have you, when we're making a decision? Well, maybe not. Okay, so let's think about a job where your qualification is directly related to your race. For instance, let's say we are looking for a Spanish translator at the UN, right? So on the whole, Hispanic people may be better qualified to be Spanish translators than non-Hispanics, right? I mean, I think it's right. It's pretty, it might be pretty easy to accept that if we just randomly picked a Hispanic person and a non-Hispanic person out of the population at large, Hispanic person is going to be a better translator, right? Easy to say. However, right. So what happens if we account for race and hiring? Right? What happens if we do what we said we did in the last example and explicitly account for race and hiring? Well, the way that you would do that is because it's a binary variable. If you wanted to make sure, if you wanted to account for race, you would just separate Hispanic and non-Hispanic applicants, and then hire at the same rate between the two different pools, right? But then now that if we do that and we've accounted for race, then this may actually be discriminatory towards Hispanic people. I mean, if the pool of Hispanic applicants is better qualified than the pool of non-Hispanic applicants, but they're both getting hired at the same rates, then there are more qualified Hispanics who are not being hired and less qualified non-Hispanics who are being hired. Okay. Whereas if we didn't look at race and we just looked at how good you are at speaking Spanish and how well qualified you are to be a translator, then we're good, right? I mean, that's right. Doesn't that make sense? Isn't that what we should do? We should just look at who has the necessary skills to be a translator and hire them. And then naturally, because Hispanic people are more skilled at speaking Spanish on the whole, we'll just hire more Hispanic people, as is justified, right? So here's a perfect example of a situation where we should totally ignore race, right? It's clearly fair in this case to just hire based on Spanish speaking ability, not worry about race, and then everything works out as one would expect it to. So here's my little what we call a causal graph, right? In this case, race has an arrow pointing towards X, right? Race determines how good you are at speaking Spanish and translating, and X determines Y, how qualified you are for the job, right? We're trying to figure out, what we want to estimate is that outcome Y, right? How qualified you are for this job. So should we model both A and X against Y? No, we should just look at X and not worry about A in this case. So what I'm trying to suggest here, we're not like this class is not, we don't need to be talking about these graphs. These graphs are heavily related, like this is what I do in my research. But the point is just to kind of, right? The point is that the difference in the structure of these graphs, right? This graph has this kind of more complex, odd structure where things are related, but the causality is a little bit muddled. It's not just one clear straight line, right? Here, the appropriate way to think about the relationship between A, the sensitive attribute, and Y is different than in this case. Yeah, let's wait for that one. Okay, so we're at about an hour. I think this is a good place to stop. Getting a curfew alert, that's fun. So I'm going to stop here. First, I'm going to take some questions with the recording on about this lecture. And then I'm going to turn the recording off and open it up to project-based questions. You can also ask about the homework, but as you heard at the beginning of the lecture, it may be better to wait, until later tonight when I've dealt with the problems in the homework to do that. Okay, yeah, so Hyung. A dead language like Latin. Right, right. Okay. So, right. So the question here, right? Here's another great question. Yeah. So, and I think what So Young means is not that different races are differently capable of learning Latin, but that to learn Latin, you often have to go to a private school, right? Public schools in the United States, at least, don't teach Latin. Private schools often do teach Latin. You need to be wealthier on the whole to go to a private school. So maybe, right, maybe Black folks or Hispanic folks are less likely to go to schools where they can learn Latin. So this is a, right, so this is a good question. So what I will tell you actually is how the law treats it. A little bit of what I do is I have to read law journal papers. I'm not a lawyer. I'm not getting a JD or anything, but the way the law treats it is that if a company can demonstrate, so if a company is sued, right, on Title VII, I think it's Title VII, uh, right, if they're sued for being discriminatory, if the company can prove that that discrimination is necessary for their business practice, then they are not held liable. So we can debate whether that's a good law or a good interpretation of the law. But what goes on right now, so what would happen in this case is if a company was like, dang, we really need some Latin translators, right? And they tended to hire white people more often than Black people on that basis. And they were sued, right, for discriminating. Then they could go, right, then the company in court could be like, look, it's crucial to our business that you know how to speak Latin. So even though we hire white people more often than Black people, we do it for a legitimate business purpose. And so we can't be held liable, and the court would side with them. However, if the plaintiff were able to go in there and say, no one needs to speak Latin these days, right? There's no job, right? I mean, for goodness sakes, the job is food delivery. You don't need to speak Latin to deliver food, right? That's not a legitimate business purpose. This company is just using Latin speaking as a proxy to discriminate against people of certain races. Then if they were able to argue that, what the heck is going on? Okay. If they were able to argue that successfully, then they would win the lawsuit. So the other, right, so let's, I mean, that ties in very directly to what I was talking about with my research on grant funding, right? I mean, we have this question, there's this issue, right? Right now, white people are much more likely to get white professors are much more likely to get grant funding than Black professors. Is that okay? Or do we need to fix that, right? If it's the case that the white professors' grant funding applications are legitimately better than the Black professors' grant funding applications, right? And that if that were the case, right, it could be the case due to, right, the fact that maybe the white professors went to, right, better undergrads and got PhDs and better graduate programs, right? And that could be the case, right, because of, right, the whole history of right, of racism and discrimination in this country, right? If they're writing better grant applications, are we not obligated to fund better grant applications? Right? So if that's not the case, then clearly there's a problem, right? If that is the case, maybe you still have an argument, right, for fixing that funding gap, right? You may say, well, shoot, even if the applications from white professors tend to be stronger, we still need to bump up the funding of Black professors, right? The serious disparity in race in these top research and teaching jobs in the country is having such a negative impact on the environment at universities, and maybe right, maybe that is counter to a goal of achieving educational equality, of making sure that Black undergraduate students are just as equally supported and mentored as white undergraduate students are in college, right? So there's right, there's many different there's different possibilities for how those disparities could arise, right? Some of which seem to be clearly sort of clearly problematic, and others less so. And then there's also different ways of addressing them, right? Different choices of how we would respond to those disparities. Neither of which necessarily seems to be fully satisfactory. So that's a longer answer than you needed, but I wanted to drive the point home. Okay, cool. Okay, are there any other questions about today's material? If you've been watching this, I appreciate it. We're gonna finish up this this topic on Wednesday, and you'll be glad you watched today, because you'll know what's going on Wednesday. And you know, I also hope that you know, that if you've been feeling a little bit helpless over the last week, what with the you know, the killing of yet another unarmed Black guy by police and the ensuing protests, that maybe you feel like there's not much you can do. Maybe you're scared to go out and protest because you don't want to be hurt, or because you don't want to contribute to the coronavirus epidemic. You know, the fact that you will all in the future, you know, a lot of you will hold positions of some power in terms of thinking about how algorithms are used to make decisions in society. You know, maybe you should take some small comfort in learning about these issues and thinking about them, and right, and being prepared in 5 years when your boss says, you know, hey, it's time to come up with a new insurance pricing model, and you're an actuary, right, and you get to decide, right, what variables to use and what not to, and how to determine, right, whether your model is profitable, whether it's fair and legal, and whether it's discriminatory or not. That maybe you have some tools for being able to do that and being able to make the right decision. Lord knows a lot of the, you know, big companies, especially tech companies in our lives, have not made the right decisions about how to deploy these algorithms, and we're all suffering from it right now. So, right, this is one small step to doing better. Okay, I am going to stop the recording. Whew.